Identify the vertices and foci of the hyperbola with this equation. All right, so how do we go about this? Well, we got to remember that there's two kinds of hyperbola. We're going to graph it, I should say. Let's basically graph this thing. That's what's going to help us out. Let's remember about the graphs. If you have x squared in the front, we don't, but I want to just lay out the possibilities. Then you make the dotted box, and the branches, if x squared's in the front, the branches will go right and left because the x-axis goes right and left. If you have y squared in the front, that's us, y squared is in the front, then with the dotted box, the branches go from the middle of the box up and down. So if y squared's in the front, up and down, x squared's in the front, right and left, that makes sense. Okay, so in our case, we have y squared in the front. So let me draw our coordinate system over here. And we're going to have a dotted box. I don't know exactly where that dotted box is. I'll just make it up. Well, that's not true. I do know where that is. Let me back that up. Whatever's underneath y is up and down, isn't it? So don't worry about anything else. Just if it's under y, it's up and down. So don't worry about which one's in the front or the back for this. If it's under y, it's up and down. So up and down 48. So we go up 48 and down 40. By the way, the center is 0, 0 on this one because there's nothing next to y and x. There's not a number like x minus 3 squared or anything like that. That would shift the center. We have nothing like that. X squared and y squared have no number next to it, so that makes the center 0, 0. So we go up 48 and down 48 because that's what's underneath y. What's underneath x is 55. Whatever's underneath x is right, left. They've already got it written as a square, so I don't have to rewrite it as a square. They already put it in the nice format for me. So it's right 55 and left 55. So that's where the dotted box sits. Let me put it in there. So that tells us how to make the box. Just like if this was an ellipse, that would tell us where to make the oval, right? Same thing. Hyperbola is very similar to ellipse. Okay, so I make that, and then you start from the middle and you shoot through the four corners the asymptote lines. Those are going to be the guidelines for the graph. Okay, so now, coming back, where do the branches go? We have y squared in the front, so the branches are going to go up and down from the middle. So from right here, up, and from right in the middle of the box, down, getting closer to those guidelines, those asymptote lines, those branches forever. Okay, so what are the vertices? Well, the vertices are these 2 points here. Vertices are this and that. What are the coordinates of that? Over 0, up 48, and over 0, down 48. So there are the coordinates of the vertices. Now, where are the foci points? I don't think I've told you that, so let's talk about that. How do we find the focus points? So let me mention. Let me make a comparison with the. Let me just say this. The focus points are always inside the branches. So here are the two focus points. They're always focused inside the branches. So how do you find exactly where are they? Well, from the center to the focus points, both cases, is C. That's going to be up C, and that'll be down C. C is what we use for the focus distance. So we have a very similar foci equation to what we used for the hyperbola. So the focus equation, to the ellipse. So the focus equation for the hyperbola is a squared plus b squared is c squared. Let me remind you if it's helpful. The focus equation for the ellipse, it was the Pythagorean theorem with a minus. So see how similar these are? For the hyperbola, it's actually exactly the Pythagorean theorem. A squared plus b squared is c squared. So again, the only difference is the sign in the middle. So here's an easy way to, you can put all this on your notes for the next exam, of course, but the easy way to remember it, the hyperbola has minus in the main equation and plus in the focus equation. It's opposite. Whereas the ellipse has plus in the main equation and then minus in his focus equation. So they switch their sign from the main equation to the focus equation. Both of them do, hyperbola and ellipse. Okay, we're doing hyperbola. We're working with this one. We're trying to find C. That's what we want to find. C, what C is how far. Let me make it clear here. C is the distance from the center to the focus points. That's what, same thing for ellipse and hyperbola. Okay, so what's A and B? A and B, you know, that's these numbers here. A squared and B squared are those two numbers. And it doesn't really matter which one you put first or second. You don't have to worry about which one's bigger or smaller because they're just added. So the order doesn't matter. So there we go. Just grab the A squared and B squared. Use your calculator, which I'm going to do right now. 55 squared, that's 3025, 48 squared, 2304. C squared, add those together. I'm getting 5329. And then we just root it. And so C equals 73. So 73 is the distance from the center to the focus. So that means this point must be over 0 down 73, and this point is up. So it's over 0 up 73 and over 0 down 73. That's where those two focus points are inside the branches. Here's the other one, over 0 up 73 and over 0 down 73. Those two purple focus points. So we use the focus equation, which is almost the same for the hyperbola and the ellipse, opposite signs. So remember, these equations, whatever sign they have in the main equation, the hyperbola has minus, then it's opposite, plus in the focus equation. For the ellipse, it has plus in the main and minus in the focus equation. Otherwise, it's the same focus equation. It's the Pythagorean theorem, basically.